Look at this first problem. What values of x make this statement true? Well, x could be 7, and that would be true. But x could also be -7, and this statement would be true. The reason is because absolute value is distance from 0 on a number line. And I know that 7 is 7 units from 0 on the number line, and -7 is also 7 units from 0 on the number line, because 7 and -7 are both 7 distance from 0. Both answers make this true. Keeping that same logic, that means that when we look at this example, if there were an 11 in here, that would be a true statement. But if there was a -11 in there, that would also be a true statement, because 11 and -11 are both 11 units from 0. So the way that you solve absolute value equations is you take your problem and you simply break it into the positive and you break it into the negative. So I will say 2x plus 5 is equal to 11, and 2x plus 5 could be -11. Notice that these values stay the same. It's what's over here that becomes the positive and the negative. Then you just solve the equations like normal. Subtract 5 over, divide by 2, and x is equal to 3. Here, subtract your 5 over, so -11, subtract 5 is going to be -16, and divide by 2, and x equals -8. Look at this next example. Now, in this example, we are saying that the absolute value of something is equal to a negative number. Well, that's not true. Absolute value, when it's still in the absolute value, has to be positive. If you are still in the absolute value, distance has to be positive. Now, up here, when I broke it out of the absolute value, that's what allowed me to say 11 and a -11. So in this situation, there's just no solution. All right, example 3. On this one, here's what you have to do first. The first thing you have to do is you have to isolate your absolute value first. So we need to get this all by itself. After you isolate, then you break. So isolate, then break. To isolate this, I'm going to add my 5 over first. That gives me 2. Absolute value of x minus 1 is equal to 6. Then this is attached by multiplication, so I will do a division and have the absolute value of x minus 1 is equal to 3. Now that it's isolated, now we're going to break it into the positive and break it into the negative. So we will say x minus 1 is 3 and x minus 1 is -3. Solve each one, add your 1, so x is 4, add your 1, and x is -2. All right, let's look at example 4, and if you'd like to, pause the video, try it on your own, then restart the video to check your answer. All right, so on this one right here, I hope that you knew that you had to isolate first. Then, after you isolate, as long as it's equal to a positive, then you break. Isolate, then break. All right, so we're going to, first of all, subtract the 2 from both sides. So I'm going to break that, and that'll be -3. absolute value of x plus 8 is equal to 15. So far, so good. But here, I have to divide by a negative 3, and I get the absolute value of x plus 8 is equal to negative 5. Well, we just said that the absolute value, if you're still in your absolute value symbols, you cannot equal a negative. So this one has no solution. And we have to stop that one. All right, number 5. On this type right here, notice that we have variables on both sides. When you have variables on both sides, that means that you have to check your answers. Either check them in your mind, or it's really much easier if you check on a calculator with your absolute value. The reason we have to do that is because we have an unknown here, and this unknown could in some way make this side of the equation negative, and absolute value can't equal something negative. So make sure you check. But you're still going to follow your logic process. Break it into the positive and break it into the negative. So if I break this into the positive, that just means it stays like it is. 3x plus 4 equals x plus 2. Over here, 3x plus 4 equals, negate it, so that will become a negative x, and that will become a negative 2. So you have to negate all the terms. Make all your signs the opposite. Solve this. I'm going to subtract my x over. So 3x minus x is 2x. Then I'm going to say 2 subtract 4 is negative 2, and I'm going to divide and get negative 1. But I have to check to make sure that's a keeper answer. Then over here, I'm going to add my x over. And then I'm going to say to subtract my 4. So negative 2 minus 4 is negative 6. Divide by 4 and either get the fraction of negative 3/2 or negative 1.5. I really think that you would be best to maybe keep that as a negative 1.5 as you're going to check. When you check, you're going to take this right here, put your x in both sides of the equation to check. So if I'm going to manually check, I'll say the absolute value of 3 times negative 1 plus 4. And then on this side, I'll say negative 1 plus 2. Well, 3, that's negative 3 plus 4 is 1. The absolute value of 1 is 1 equals 1. This is a true statement, so that means this one is going to check. On the other side, I'm going to have 3 times negative 1.5 plus 4 inside the absolute value. And I'm going to have negative 1.5 plus 2 on this side. So over here, I'm going to get a 0.5, a positive 0.5. Over here, I get a positive 0.5. That's also a true statement. So this one checks as well, and we can keep both answers. All right, let's look at example 6. And if you'd like to, pause the video, try it on your own, and then come back and check your answer with me. All right, so we're going to break it into its two parts, break it into the positive, and break it into the negative. So breaking it into the positive says you have 2x plus 1 equals 3x minus 5. That's where you write it just as you see it in the original problem. Now, when I break it into the negative side, you're going to keep this just the same, but it's this side over here that you want to negate all the terms. So that will be a negative 3x and a positive 5. Solve the equation just like you normally would. Subtract your 3x over, so 2x minus 3x is negative x. Negative 5 minus 1 is negative 6. Divide by negative 1 and x equals 6, or so we'll see. Here I'm going to add 3x over, and then I'm going to subtract my 1 and get 4. And I get 4/5 or a 0.8. But we have to check those answers. So we're going to go back and check into the original. You're going to check them separately. First of all, put your 6 right here in both sides, and you're going to see that you get a true statement. It checks. Then you're going to go back and put your 0.8 in. Over here, you get 2.6 when you check it on the left side, but you get negative 2.6 when you check it on the right side. So that does not check, and you have to throw that answer out. All right, last one. To solve this right here, I need to isolate first. Remember that you isolate and then you break. So isolate, then break. To isolate this, that is attached by multiply, so I have to divide every one by 6. So as I do that, that gives me the absolute value of 2x plus 5 equals x plus 4. All right, now we're ready to break it into the positive side and to break it into the negative side. And again, if you'd like to pause the video and try it on your own and come back and check with me. All right, so 2x plus 5 is equal to x plus 4. 2x plus 5, remember over here you're negating, so you're changing the signs of everyone. So that's going to turn into a negative x and a negative 4. Subtract your x over, subtract your 5 over, and you get x equals negative 1, but we'll check it to be sure. Then here we're going to add the 3 over, subtract your 5 over, so negative 4 minus 5 is negative 9, and x equals negative 3. Make sure you go back to the original problem. That's just like you saw it on the page, and you're going to put in a negative 1 right there, and make sure the left side equals the right side, and it does, so you keep this answer. Then you're going to do the same thing with your negative 3. Put a negative 3 here and a negative 3 here, and make sure that the left side equals the right side, and it does. So you get to keep both answers this time. If you need more help, be sure to watch my teaching video on absolute value equations. There you can watch me explain and work more examples. Hope to see you soon.